Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on flow through parallel pipes. So in our previous lecture, already you have discussed the theory part related to the flow through a parallel pipes. So in this lecture, let's solve a problem related to the flow through parallel pipes. So here I have taken a question. A main pipe divides into two parallel pipes. So one pipe is divided into two parallel pipes, which again form a one pipe. The length and diameter for the first parallel pipe are 2000 meter and 1 meter respectively, while the length and diameter for second parallel pipe are 2000 meter and 0.1 meter respectively. Find the rate of flow in each parallel pipe if the total flow in the main pipe is 3 meter cube per second and the coefficient of friction for each pipe is equal to 0.005. So it's very simple. If you have seen the previous video, you can understand this problem very easily. So the question is given, like, this is a pipe is there, and in this pipe there is a liquid is flowing, and this pipe is branched into two pipes. Okay, so after dividing two pipes, again it joined, again it formed as a one pipe. So let's see how you can draw, like, okay. So this is the pipe construction is there. Now how you can divide this flow if you joined a connection here. Okay, so it will be divided into two. Now suppose this is the fluid is flowing with a flow rate of Q, and this fluid is dividing into two different branches. Now this is one branch and this is another one branch. After dividing, again after Q, again it is forming as a one pipe. Okay, that means what is the Q is here, discharge rate of flow is there, the Q is divided into Q1 and Q2, and after some time again when it is form 1, again it is Q. Okay, so for this, so this is suppose pipe 1 and this is pipe 2, this is pipe 2. Now the length and diameter, now suppose this is the length of this pipe is there, this is the length of the pipe L1 and this is the length of the pipe L2, and this is pipe 2, and the diameter of this pipe, this is nothing but D2, and diameter of the pipe is D1. Okay, now the rate of flow Q is given, so let's write down what are the data are given in this question, then we'll go for the solving of this question. Now the data is given here, you can see first one, the length and diameter of our first parallel pipe. So this is one parallel pipe 1. So L1 is given 2000 meter, and for the particular pipe 1, we have the diameter D1 equal to 1 meter. Okay, while the length and diameter of the second parallel pipe, this is the second parallel pipe, which length is given, L2 is given, also same length, so there is no change in length, only there is a change in diameter. So here diameter is 0.8 meter, and find the rate of flow for each parallel pipe. For this parallel pipe also we need to find out the Q, so that means this is Q1, and for this parallel pipe 2 we need to find out the rate of flow, this is Q2. If the total if the total rate of flow, that means Q, the Q is given here 3 meter cube per second. So total flow is given, and the coefficient of friction for each pipe, for this is the coefficient of friction is F, and for this pipe coefficient of friction is F2, this is F1, this is F2. For both the pipe coefficient of friction is same, equal. So you cannot, no need to write F1 and F2, we can write only simple thing, you can write here F1, F2, both are same, and the value is 0.005. Okay, now we need to find out the discharge Q1 and Q2. So to identify this or to solve this problem, we have what we discussed in our previous lecture. So we can use that Darcy-Weber's equation that through the pipe flow, when the fluid is flowing through a pipe, and suppose this is the length of this pipe is there, this one, and this is the length of this pipe. So for this the losses or the head loss or the fluid which is flowing through a pipe. So the loss of energy due to the major loss, or that is due to the friction. So for that we have already derived previously. So we got the equation, that is nothing but we can write 4F LV square by 2dg. So this is we need to take for pipe 1. That means we need to mark L1 F1 V1 square D1. Okay, equal to, so equal to, we can write same should be there, Q1 and Q2. So this is 4F2 and L2 V2 square divided by 2d1g. Now if you see in this equation, okay, this equation we have taken previously, because while solving the theory part, there we got this equation. And here what we can cancel this one, few value we can cancel, like 4 f is same, so 4 cancel, f cancel, and 2g everything we can cancel. Now after cancelling all the things, what we'll get here, only L1. So L1 also same value is there, L1 L2 same value, so here also you can cancel it. So what we'll do, let cancel this, and we can write finally this is V1 square by this is D1, and this D1 value also you can write it there, and this is V2 square by D2. And if now see here, velocity values are not given. So what is my intention is, I'll identify some value of V1 or V2, then I'll put that V1 and V2 in terms of like discharge equation, Q equal to AV equation. Now so let me consider a suppose V1 now D1 value, how much? D1 value is 1. So 1, if you take it that side, there is no impact on that 1. So what I can write here, V2 square divided by 0.8. This is V1 square. Now I'll just write the value of V1 only. I can see here, I can find out the value of V1, or I can find out the value of V2. Anyone I can do. So what I'll do, I'll just take it to V1 value. So V1 value is nothing but we can write V2, the square I have taken out, and so root over of this 0.8. So this is the value of V1. Okay, now what I'll do, I'll just put this value of V1 in the discharge equation. So we know that the discharge equation is, we can write Q1 equal to A1 into V1. So A1 is nothing but pi by 4. This is D1 square into V1. So just put the value of this, all these things, pi by 4. D1 is 1, so there is no effect, and V1 value is here. I can what I have written there, same thing I can write it here. So that is V2 divided by root over of 0.8. So what I'll do, 0.8 root over of this 0.894. So this is nothing but 0.894. So the same thing I can write it here. Now similarly, we can find out Q2. So Q2 also you can write it here, A2 V2, A2 V2, and here also I can write the same thing, pi by 4 D2 square. D2 square value is 0.8 square into V2. So finally what we can write, pi by 4 into 0.64 into V2. Okay, so here also V2, here also V2 is there. So there is no question of V1. Only one velocity we can easily identify from the question. Now we know that, now see, this is the Q. So Q is the total rate of flow, which is supposed to be equal to Q1 plus Q2. So what I can write here, now I can write Q equal to Q1 plus Q2. So what is the value of Q? That is 3. So the total rate of flow should be equal to the rate of flow in the pipe 1 and the rate of flow pipe 2. So by adding this one, we can get the same thing. Okay, so this one given equation 1 here. Okay, now what I'll do here, I'll just put these values of Q1 and Q2 in this equation, so it will be easy to identify some velocity value there. So just put the value of, like, Q1 is pi by 4 into V2 divided by 0.894 0.8894 something is there, and plus we can write pi by 4 into 0.64 into V2 equal to 3. Okay, now what I'll do, I'll just solve this thing, then I can finally write some value in terms of V2. So let's solve this one. Yeah, so pi divided by 4 again divided by 0.894, so this is 0.878. so I can write, what I'll write, 0.878, this is V2. Okay, plus again the same thing I can do it here, that means pi divided by 4, yeah, multiply 0.64, so this is 0.502. so same thing I'll write here, this is 0.502, this is V2 equal to, this is 3. so finally in then velocity how much we'll get here, so V2 equal to 3 by this value. So let's see how much is there, this one plus 0.878, 1.380. so we can write 3 by 1.380. so this is 3 divided by 1.380, 2.17. so this V2 we got 2.17 meter per second. Okay, now so one velocity we got means second velocity also we can easily find out, because same value we can put it here, we can find out the value there. So what I'll write here, just put this value, let me draw a line. So now V1 value I got, no, V2 value I got, so I'll put this value in this equation. So this is 2.17 divided by this 0.8 we have divided 0.894, so we got 0.894 I hope. And if you divide this, how much, so let's see, divided by 0.894, 2.431, so 2.43, let's write 2, after that 6 is there, so let make it the value 2, to 2.432 meter per second, 2.4327. okay, anyway the same thing. Now V1 value, V2 value we both you got. Now what is our final aim? We need to find out the discharge individual rate of flow for each pipe. Now same thing, just we put the value of Q1. Now see, Q1 equal to, we can write here, already this value is there, pi by 4. This one also you can write pi by 4 again. And what is the value of V1? Just to put pi by 4 d square, that means 1 square into V1. V1 value is this one, 2.432. How much? Similarly Q2, discharge 2, pi by 4 into, this is 0.8 square into, what is the value of V2? V2 also we got here 2.17. So let's calculate this one by one. So this is pi into 2.432 equal to, divided by 4, 1.91. so this is 1.91 meter cube per second. Similarly second discharge how much? So similarly this is pi into 0.8 into 0.8 into 2.17, this divided by 4, 1.075 meter cube per second. So again just you add these two things, plus 1.91 something will get it there, 2.990. if you add these two things, what should supposed to be 3. So same value we got, 2.99 something value we are getting, so we can consider that is 3. So the 3 meter cube per second, that is the discharge in the pipe. So finally, this is the individual rate of flow for individual pipes. Okay. Finally, if you add these two things, you will get the same discharge, which is initially when it is entering to the pipe. So I hope you understand this problem. It's quite simple, but if you understand the theory part of this, then only you can understand this problem, like from where we have taken this formula and how this formula was there. So it is all are interlinked. This formula came from the Darcy-Weber's equation by the measure loss. So this measure loss is considered only for the when it is pipe flow without any kind of bend or any kind of minor losses. So from there we can find out one by one. This is continuity equation. We need to consider A1 V1. So rate of flow equation we can consider this is Q1 equal to A1 V1, Q2 equal to A2 V2. Then from there we can find out the velocity, and we can put the velocity in the discharge in the rate of flow, and we can find individual rate of flow. Okay, so I hope you understand this problem. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.